In 2012, a deep learning system called AlexNet, created by Geoffrey Hinton and his team, shocked the world at the ImageNet challenge. The model reduced image recognition error rates from about 26% to 15%, a massive improvement in computer vision. That single breakthrough proved neural networks could outperform traditional algorithms, triggering a surge in AI investment and research that continues today. By 2020, AI research accelerated with transformer models such as GPT-3, developed by OpenAI. GPT-3 contained 175 billion parameters, far larger than previous language models. It could generate essays, code, and conversations. Within months, developers built thousands of applications using its API, showing that large language models could become general tools for writing, programming, and problem solving. The real turning point came in late 2022 when ChatGPT launched publicly. Created by OpenAI, the chatbot gained over 1 million users in just 5 days, faster than any consumer application before it. By early 2023, it surpassed 100 million users, demonstrating that AI assistants could become a mainstream technology used daily for learning, coding, and productivity. Another major breakthrough involved hardware. AI training relies heavily on powerful GPUs like those produced by NVIDIA. The company's NVIDIA A100 GPU can perform trillions of calculations per second. Training a modern large model can require thousands of GPUs running for weeks, consuming millions of dollars in computing power, but enabling AI systems to learn from vast datasets. The scale of AI data is staggering. Models such as GPT-4 are trained on massive text datasets that may include hundreds of billions of words. According to industry estimates, training a frontier AI model can cost over $100 million in computing resources. These investments show how seriously governments and technology companies view the race to build more capable AI systems. AI is also transforming programming. Tools like GitHub Copilot, built by GitHub and powered by OpenAI models, can automatically generate code. Studies show developers using Copilot complete tasks up to 55% faster. This shift suggests software development may evolve from manual coding toward collaboration between human engineers and intelligent AI assistants. AI breakthroughs are rapidly changing healthcare. Deep learning systems can analyze medical images faster than human specialists in some tasks. For example, AI models trained on radiology data can detect certain cancers with accuracy rates above 90%. Hospitals and research groups are now integrating AI into diagnostic tools to help doctors detect diseases earlier. The economic impact is enormous. Analysts at McKinsey Company estimate generative AI could add $2.6 trillion to $4.4 trillion annually to the global economy. Industries such as marketing, software engineering, finance, and customer service are already adopting AI automation to increase productivity and reduce operational costs. Governments now see AI as strategic infrastructure. Countries including the United States and China invest billions in AI research and semiconductor manufacturing. Control of AI technology increasingly influences economic power, military capability, and global competitiveness, making artificial intelligence one of the defining technologies of the 21st century. Today, the next frontier is artificial general intelligence, often called artificial general intelligence. Companies like OpenAI, Google DeepMind, and Anthropic are racing to build systems capable of performing any intellectual task a human can do. Experts believe such systems could transform science, economics, and society within the next few decades. In 2017, researchers at Google introduced a paper titled "Attention is All You Need." This work created the transformer architecture used in modern AI systems such as GPT-4 and BERT. Transformers process words in parallel rather than sequentially, making training far faster. This innovation allowed language models to scale from millions of parameters to hundreds of billions. AI models are growing at an unprecedented rate. Early neural networks in the 1990s had thousands of parameters. By contrast, modern systems like GPT-4 are believed to contain hundreds of billions to trillions of parameters. According to researchers at Stanford University, the computing power used to train frontier AI models has increased over 300,000 times since 2012. Training these massive systems requires enormous infrastructure. A single advanced AI model may use 10,000 or more GPUs running simultaneously. Data centers built for AI can consume tens of megawatts of electricity, enough to power thousands of homes. Companies like Microsoft and Amazon now invest billions each year to expand AI cloud infrastructure. AI breakthroughs are not limited to language. In 2020, DeepMind introduced AlphaFold, a system capable of predicting protein structures. Scientists had struggled with this problem for over 50 years. AlphaFold predicted the shapes of over 200 million proteins, potentially accelerating drug discovery and biological research worldwide. Generative AI has also transformed creative industries. Tools like Midjourney and Stable Diffusion can generate detailed images from simple text prompts. Millions of users now create artwork, advertisements, and illustrations in seconds. The speed and scale of AI-generated content are changing how digital media is produced. Video generation is the next frontier. Systems such as Runway and experimental models from OpenAI can generate realistic video clips from text descriptions. Analysts estimate that AI-assisted video production could reduce production costs by 30 to 60%, dramatically altering filmmaking, marketing, and online media creation. AI is also accelerating scientific discovery. Researchers now use machine learning to analyze massive datasets in physics, chemistry, and astronomy. In drug development, AI models can test millions of molecular combinations digitally before laboratory trials begin. This approach may shorten drug discovery timelines from 10 years to just a few years. The global AI market is expanding rapidly. According to estimates from PwC, artificial intelligence could contribute $15.7 trillion to the global economy by 2030. Industries including healthcare, manufacturing, logistics, and finance are integrating AI systems to automate processes and uncover insights from massive data sets. However, the rapid progress raises serious concerns. Experts warn that advanced AI systems could generate misinformation, automate cyber attacks, or disrupt labor markets. Governments in regions like the European Union have begun introducing regulations to ensure AI technologies remain safe, transparent, and accountable. Despite the challenges, the pace of innovation continues to accelerate. Companies such as OpenAI, Google DeepMind, and Meta are investing billions into next-generation models. Each new breakthrough pushes artificial intelligence closer to systems capable of solving complex problems once thought impossible. Artificial intelligence investment is expanding at a historic pace. In 2023 alone, global private investment in AI exceeded $67 billion, according to Stanford Institute for Human-Centered Artificial Intelligence. Major companies including Microsoft, Google, and Amazon are committing billions to build advanced AI models, cloud infrastructure, and specialized hardware designed specifically for machine learning workloads. The demand for computing power has made AI chips one of the most valuable technologies on Earth. Graphics processors from NVIDIA dominate the market for AI training. Its H100 GPU can perform trillions of calculations per second. Some advanced AI clusters use tens of thousands of GPUs, creating computing systems powerful enough to simulate complex scientific and economic problems. AI data centers are becoming strategic assets for nations. Countries like the United States, China, and Japan are investing heavily in high-performance computing facilities. Some AI data centers require over 100 megawatts of electricity, enough to power entire small cities. This infrastructure is now considered essential for national technological leadership. Artificial intelligence is also transforming education. Platforms powered by systems such as ChatGPT and learning tools from Khan Academy can act as personalized tutors. Studies show AI-assisted tutoring can improve learning outcomes by up to 30%, especially in subjects like mathematics and programming where step-by-step explanations are critical. In finance, AI systems analyze vast streams of market data in real time. Banks and hedge funds increasingly use machine learning models to detect patterns across millions of transactions. According to industry reports, algorithmic trading now accounts for over 70% of stock market trades in the United States, showing how deeply automation has entered global financial systems. In finance, AI systems analyze vast streams of market data in real time. Banks and hedge funds increasingly use machine learning models to detect patterns across millions of transactions. According to industry reports, algorithmic trading now accounts for over 70% of stock market trades in the United States, showing how deeply automation has entered global financial systems. AI is also transforming logistics and transportation. Companies such as Tesla and Waymo are developing autonomous driving systems trained on billions of miles of data. These systems rely on neural networks that process camera, radar, and sensor data in real time to understand roads, traffic patterns, and pedestrian behavior. Manufacturing industries are increasingly powered by intelligent automation. Smart factories use machine learning to monitor equipment performance and predict failures before they occur. Research from World Economic Forum suggests predictive AI maintenance can reduce machine downtime by up to 50%, while lowering maintenance costs by nearly 30%. AI is also revolutionizing cybersecurity. Security systems now use machine learning to detect abnormal behavior in massive computer networks. By analyzing billions of data points, AI tools can identify suspicious activity within seconds. Companies such as CrowdStrike use AI-driven platforms to defend organizations against increasingly sophisticated cyber threats. However, experts warn that powerful AI models could be misused. Deepfake systems built with generative models can produce realistic fake videos and voices. Researchers estimate that by 2026, synthetic media could represent over 90% of online content, raising major concerns about misinformation, fraud, and digital identity verification worldwide. Despite the risks, AI progress continues rapidly. Leading research labs such as OpenAI, Google DeepMind, and Anthropic are developing new systems that can reason, write software, and assist scientific research. Each breakthrough pushes artificial intelligence closer to becoming a fundamental technology shaping every industry and aspect of modern life. Artificial intelligence is transforming software development. Tools like GitHub Copilot, developed by GitHub with models from OpenAI, assist programmers by generating code automatically. Internal studies show developers using Copilot complete coding tasks up to 55% faster. Millions of programmers now rely on AI assistants to write functions, debug errors, and explore new programming frameworks. AI is accelerating medical research at an unprecedented scale. Systems from DeepMind and pharmaceutical companies analyze vast biological datasets to identify promising drug compounds. Traditional drug discovery can take 10 to 15 years, but AI-assisted methods may shorten early discovery phases by 30 to 50%, allowing scientists to explore millions of chemical possibilities before physical laboratory testing begins. The workforce impact of artificial intelligence is widely debated. Analysts at Goldman Sachs estimate that up to 300 million jobs worldwide could be partially automated by generative AI technologies. However, automation historically creates new roles as well, especially in engineering, AI system management, and data analysis, reshaping labor markets rather than simply eliminating work. Major technology firms are competing intensely to dominate AI platforms. Companies including Microsoft, Google, and Meta are investing tens of billions of dollars into research labs and cloud infrastructure. This competition drives rapid improvements in model performance, but also raises concerns about market concentration and control over powerful technologies. Major technology firms are competing intensely to dominate AI platforms. Companies including Microsoft, Google, and Meta are investing tens of billions of dollars into research labs and cloud infrastructure. This competition drives rapid improvements in model performance, but also raises concerns about market concentration and control over powerful technologies. Energy consumption is becoming a key challenge for advanced AI systems. Training a large model can require millions of kilowatt-hours of electricity, comparable to the annual power usage of hundreds of homes. Researchers in companies such as NVIDIA are developing more efficient processors and cooling systems to reduce the environmental footprint of large-scale AI computing. Governments are responding with new regulatory frameworks. The European Union introduced the AI Act, one of the first comprehensive attempts to regulate artificial intelligence. The law classifies systems based on risk levels and requires transparency for high-impact applications, particularly those used in finance, employment, security, or public infrastructure. Education systems are adapting quickly. Universities and training platforms increasingly teach AI-related skills such as machine learning, prompt engineering, and data analysis. Enrollment in artificial intelligence courses has grown dramatically at institutions like Stanford University and Massachusetts Institute of Technology as demand for skilled AI engineers continues rising. Some scientists believe artificial intelligence could help solve humanity's hardest scientific challenges. AI-assisted simulations are already being used in climate research, particle physics, and materials science. By analyzing enormous datasets, AI systems can identify patterns that might take human researchers decades to discover using traditional methods.